Everybody, buckle your seatbelts because it's time for the free response questions. All right, here we go. Problem 1. Given a projectile launched with the speed v0 at an angle theta. Oh, hey, everybody. Earthquake drill. Well, I paused the video, so while you're debriefing about the earthquake drill, I'm going to calculate the maximum height to which this object rises. So, I will use the formula v squared is v naught squared plus 2a y minus y naught because as has been said before, no, I'm not. Okay. Now, it's a speed of 0 at the top. Its launching speed is v naught sine theta squared minus 2g times the height that it's going to get to. And when we rearrange that, we're going to get h equals v naught squared sine squared theta over 2g. Now, let's determine the object's hang time, shall we? So, v equals at plus v naught, but let's use our projectile equations. 0 equals negative g times t plus v naught sine theta. This is just the time to go up. So we're going to end up getting that the time is v naught sine theta over g. So we're going to double this time. So the hang time is going to equal 2 v naught sine theta divided by g. So there's the height, there's the hang time, but wait, there is more. We're going to get the range. Range equals v naught cosine theta times the hang time, because you're going in the x direction, times the time you travel for. So that's going to be v naught cosine theta times 2 v naught sine theta over g. And so when we simplify all this out, this is going to be v naught squared 2 sine theta cosine theta all over g. Or you can simply write this as v naught squared sine of 2 theta divided by g. And that's our range. All right, I believe, yeah, that is the first problem on this part of the practice test. I'm actually going to try to go through, I think all these would be good to go through in one go. So let's draw a free body diagram here. So we have the normal, we have the weight, and then we're going to have mg cos theta going this way, mg sine theta going that way, and a possible friction. Now, the acceleration of the block in the absence of friction, you have mg sine theta equals ma. The m's cancel, so a equals g sine theta. All right. Now, assume the block slides down the ramp and accelerates. So we're sliding down the ramp, so what that means is mg sine theta minus the friction equals m times a. And in the y direction, we know that n minus mg cos theta equals 0. We're going to use this to get the friction because the normal force is, in fact, mg cos theta. That leads to the conclusion that since friction is mu times n, that's going to be mu k mg cos theta. When we plug that in there, we're going to get mg sine theta minus mu k mg cos theta equals ma. Our m's cancel, and so we're going to get an acceleration equal to g sine theta minus mu k cosine theta. Now it says, if the block slides down the inclined plane at constant velocity, prove that the coefficient of friction of mu k equals tangent of theta. Here's a trick. A equals 0. So 0 equals g times the sine of theta minus mu k cos theta. I can actually divide out the g, so I'm going to get mu k cos theta equals sine theta. Or in other words, when I divide both sides by cosine, mu k equals the tangent of theta. All right, that's problem 2, and we'll take a look at problem 3 right now. Ew. Haha, it's already done. Free body diagram. Now let's write but not solve the differential equation. Let's just remember we have Fg minus Fd is ma from Newton's second law, which is F equals ma. But here we're going to have mg minus kv equals m. And where you see the a, write dv dt. And you are done. Now, terminal speed when it falls. That's going to be mg minus kv equals m times 0, because at terminal speed, a equals 0. So we're going to end up getting that kv terminal equals mg. So v terminal equals mg over k. And let's be clear. When we drop the ball, it starts from rest, and it's going to reach terminal speed eventually. So this actually kind of becomes a horizontal asymptote right there. And then here for the acceleration, we start off with the acceleration of g, and then as time goes on, that acceleration dies off to 0. And that's what happens with the g graph. All right, so that is question 3. We will look at the actual AP problems in the real free response, kind of challenging, fun, delightful AP physics problems next.